All right, here we are at the FRQ, as they say. There's 4 of these on the practice test. There's 4 of them on the real test, too, and this one is designed to look like the ones that you would see on the practice test. So the function g is graphed below. Looks like we got ourselves a nice little asymptote, stuff like that. G of x has a vertical asymptote at x equals -3. I can see it. And 2 labeled coordinates, -1, 2, and 1, 1. Additionally, f of x is defined by the function f of x equals 6 over x squared minus 9. So we got 2 different things going on. We have g of x, which looks like this, and f of x, which looks like that. Lock that in. A part 1. K of x is defined, it's also designed by me, and defined by k as f of g of x. F of g of x. So k of -1 is us trying to find f of g of 1, and let me put that as a different color. F of g of -1. Oh, that was a close one. When I made a video of these last time, I accidentally plugged in the wrong number. I got a lot of comments on it, so I almost did it again. Oops, Britney Spears would say, because she did it again. So g of -1. What is g of -1? Well, g comes from this guy, and g of -1 is 2. G of -1 is 2. So g of -1 is 2. So now I have to find f of 2. F is defined as x over x, 6 over x squared minus 9. So f of 2 is going to be 6 over 2 squared minus 9, which simplifies to 6 over 4 minus 9, which simplifies to 6 over -5. But since I'm running out of space, let's just throw the negative out there and say that that is our answer for A. So let me just wrap it up. K of -1 equals -6 over 5. Bada bing! That's A part 1, or I. Part 2 is asking you to find all the vertical asymptotes of f of x, or indicate if there are none. F of x is given to us by that. Vertical asymptotes exists when the denominator is equal to 0. So x squared minus 9 equals 0. 2 ways you could do this. You can add 9 to both sides and square root, or you can factor this out. X plus 3, x minus 3. The zero product property has me setting each parentheses equal to 0, or as I know by now, the magic number for that parentheses is going to be -3, and the magic number for that parentheses is going to be +3. So I'm going to write out that the vertical asymptotes are x equals -3 and x equals +3. Now, I'm writing them both out because the vertical asymptotes is technically a vertical line. X equals -3 and x equals regular 3, I think would just be the proper way of writing it out. All right, so part 1, or problem 1, part A, complete. That's 2 out of the 6 parts that you're going to see on this guy. Part B, problem 1, same exact question above, don't need to repeat it. Find all the values of x as decimal approximations for which f of x is equal to -4.1. So what I need to do is I need to take that guy, and I need to find out when it's equal to -4.1, and that's going to require our calculator. The first 2 problems of the free response question are calculator problems, and I'm going to want a calculator for this guy. So let's go over there. And before I go over there, let me explain what I'm going to do. Okay, I'm going to type this first guy in to the y equals part. And so, I'm pretending that this is a TI-84 plus. And in the second line, I'm going to type this guy in and find out where these guys intersect. Now I'll go over to the calculator part. All right, let's graph these puppies. I've got my first equation being 6 divided by, make sure you put the entire denominator in parentheses, otherwise your calculator will not know what you're talking about. OTI-84 plus, you're very reliable. Not joke. Now, we were supposed to solve when this guy was equal to negative 4.1. So I'm doing systems of equations stuff right here, and I'm doing negative 4.1 to the other one. When we hit graph, we're going to see a blue line and a red line cross. My gosh! Not only do they cross once, they cross twice. Who would have thought? Well, what I have to do is find out where these guys intersect. So I'm going to hit second, trace, and I'm going to hit 5 for intersect. Let's do the one on the left. So I'm going to move to the left, and I'm going to hit enter, and then I'm going to move to the right for second curve and hit enter, and for guess, hit enter. And it's going to tell me that one of my x values is negative 2.7452, blah, 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 blah. Okay, now since this was like a pretty looking denominator, and we found out that the vertical asymptotes were 3 and negative 3, we probably know what the other x value is going to be. But listen, I get paid by the second, so why don't we keep going? Let's hit second trace again to go to calc, go to 5 again to intercept, and let's find the other one. To the right, to the right, to the right. Cupid shuffle. Remember that? Remember that dance from like 2008? Hit enter again, hit enter for guess, no sign change. What did I do? All right, let's try it again. Trace, second trace. I thought I hit intersect. So, you know what? I think I know what I did. I wonder if I accidentally jumped over to that graph. This is a good mistake that happened. Enter. Let's move to the right just barely. Enter, enter. Yeah, and that seemed to work. So as you saw, when I tried finding this one, it yelled at me and said, no, you did it wrong. I wonder if by moving right too many times, it tried to find the intersection of the red line and this part of the blue line, which there is none. So, a happy little mistake occurred. But we got what I figured we'd get, 2.745. So we get the negative version of that and the positive version of that. So let's go back and write it out. All right, so as you saw when we tried to do the graphing part, we got two of the same number basically, but one's positive and one's negative. So x equaled negative 2.745 and positive 2.745. And again, the fun thing that happened there is we had a little error pop up when we tried doing it. And it's always kind of good to play around with your calculator and see when things screwed up. And it did there, and we kind of probably figured out why. But, happy little mistake. TIs are not perfect. Not the wrapper and that calculator. If you don't know what I'm talking about, there's a wrapper named TI. That was problem I, BI. And now let's do BII. So determine the end behavior of f of x. So again, that's this guy here. As x increases without bound. Now, what does that mean? That means the limit as x approaches positive infinity. The limit as x increases without bound means x is going to keep going to the right, to the right, to the right. Cupid shuffle again. Now, if it said decreases without bound, it would be negative infinity. The fortunate thing about this is the answer is going to be exactly the same. Now, I'm not going to run to my calculator. Maybe you remember what the picture looked like, but I'm going to do this without the use of a calculator, without the picture. Okay, f of x is given to us as 6 over x squared minus 9. What you do when you're asked to find the limit as x approaches any infinity of a rational function is you take the leading term of the numerator and the leading term of the denominator and simplify it. And if you're like, it won't simplify, you're absolutely right. If the denominator's degree is higher, you're always going to get 0 no matter what. And that's because if you keep plugging in numbers, like if you plug in 5, you'll get 6 over 25. That's like point something. If I were to plug in 10, you get 6 over 100. That's going to be 0.06. Plug in 1,000, plug in 10,000, plug in 1,000,000. You're going to get a really, 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 really small number like 0. It's never going to hit 0, but it's going to be close enough where you can finally say, you know what? I give up. The limit as x approaches infinity of f of x is going to equal 0. So that's how you find out the end behavior as f increases without bound and expressing it in limit notation. So there you go. Isn't that neat? Limits. All right. Part B, denzu. Part C. The function g is oh yeah, it's the same one. I don't need to do this. All right, so this is what g looks like. Again, we've got very similar kind of to what we just saw in F, but this one only has one, okay, vertical asymptotes. It's asking if g is invertible. Now, what does invertible mean? Invertible means, can you find the inverse? Okay, now the inverse exists if you can take what's called the horizontal line test. Now, the horizontal line test says if I were to take a line, and let's put a line there. I tried to, it wouldn't let me. Let's see if it will do it again. If I could take a line, do I have a line? I hit the button. Let's try it one more time. Can I take a horizontal line and pass it through the red graph and have it hit more than once? So, no. Now here, I have a horizontal asymptote, which means it doesn't pass the red line more than once. No. So the quick answer to this, guys, is G invertible? Well, the answer to CI is yes. Now, here's the frustrating thing about the AP exam. Part 2 is asking to give a reason. Using the phrase, yes, because it passes the vertical line test will not fly for the AP exam. Why? It just won't. Remember, if you have a regular function, okay, its inverse is when the x's and the y's swap. So what we could say is for every y in g of x, each y is mapped to exactly 1x. What that means is, if you're remembering like things like these, like what were these called? Mapping diagrams, and you were asked, this is back in 8th grade, you were asked to find out if something's a function, you would be like, no, it's not. Well, now I kind of care about it in the opposite direction, right? Well, every y is mapped to exactly 1x. Now, why does that matter here? So, when taking the inverse, right? When you take the inverse, every x in G inverse is mapped to exactly 1y. That's not how you spell exactly. Exactly 1y. So again, if I were to pick, like, I don't have points, but there was another problem that I did where I gave you points. And so if you had points like 1, 2, 2, 4, 8, 6, right? If this was g of x, and I were asked you to find g inverse of x, okay, you would say 2, 1. 4, 2. You would flip the x and the y, right? And as you can see, once I flip them, the x's don't repeat. Well, that's what's going on here. Since the y's don't repeat in this picture, once I flip them, the x's won't repeat in the picture. So that's problem 1 in my ultimate practice test. It's designed to look like problem 1 in version 2 of the practice test found on AP Classroom. Is it the same? No. Is it similar? Yes. So if you were to watch this and do that, you'll primarily get a very similar thing. Okay? So that's it. Hope this helps. The second FRQ in 4 problems that we're going to see on every AP Precalculus exam is about an object launched straight up with an initial velocity of 19.6 meters per second from a height of 58.8 meters. The table below gives 3 data points displaying time after the object is launched in the air, in seconds t and height h of t. So after 1 second, the object is that high in the air. After 2 seconds, it's that high in the air. After that seconds, it's that high in the air. So you can see that this guy is, shot up at 58 and then comes down, hits the ground at some point. Okay? Looks like I'm trying to draw a hangman, and that's not what I'm doing. The object can be modeled by the equation. Oh, it's quadratic, like I guessed it would be. Use the given data to write 3 equations that can be used to find the value for constants a, b, and c in the expression for h of t. So a, I, scares me because of artificial intelligence. Use the given data to write 3. Did I say that already? I think I did. So I have to write out 3 equations using this information and using that information. I don't have to solve it. I don't have to find it. I just need to write it out. So if your t and your h of t, one of my equations is h of t is 73.5. So I'm using this information right here. Equals a1 squared plus b times 1 plus c. That's one equation I could use. The other equation I could use is 78.4 equals a2 squared plus b times 2 plus c. And the third equation that I can find is going to be 34.3 equals a5 squared plus b squared plus b times 5 plus c. 3 equations, 1, 2, 3. Check, check, and check, baby. Now let's do the double I. Okay, the double I. Find the values for A, B, and C as decimal approximations. Well, we know that this is a calculator problem, so what I can do is I can run to my calculator and use quadratic regression. Okay, so let's run over there and do just that. All right, quadratic regression, just like any regression, starts with you going to Stat, hitting Edit, and plugging in the values that you had. The one value that we had, well, the 3 x values, or in our case, the t values were 1, 2, and 5. That matched up with 73.5, 78.4, and 34.3, respectively. All right, we need to do a quadratic regression. So stat again, calc, and quad reg is number 5. So go down to 5 or hit 5. And usually when we do this, we would go down to store regression equation and save that. I'm going to show you how to do that just in case you've never seen it before. Vars, you go down the store reg EQ, go to vars, y vars, function, enter. And then what that's going to do once I hit calculate is save that in here. Now, normally I would do that, but when I go back and forth when making these videos, every time I go back and forth, I lose all this information anyway. But that's all right. I'm going to hit calculate, and this gives me exactly what I need. And if I were to use the equation later, there it is. It's a mess, but negative 4.90000 is basically the same thing as negative 4.9. So negative 4.9, 19.6, C is 58.8, and it gives it to us quite nicely. So that's all we have to answer it. We just have to say what A, B, and C is. We don't have to build the equation ourselves. So let's go back and do that. All right, so using quad reg, we were given A equals 70, nope. Okay, so using quad reg, we were given A equals negative 4.9, B equals 19.6, and C equals 58.8. And if your teacher ever had you do any gravity problems, these numbers should look kind of familiar, especially that guy right there. I mean, that guy gave us our height, which is that guy right there. So it all worked out nicely. So that's part A, writing out useless equations, but actually finding the equation that we would need. B is a 3-parter, and B part 1 is asking us to use the given data to find the average rate of change from times t equals 1 second to t equals 5 seconds. Now, there's two ways you can handle this. You just came up with an equation. You could use the equation in your calculator to do the math for you. But what I'm going to do is the fact that it gave us t equals 1 and t equals 5. And look, t equals 1 and t equals 5. So the average rate of change is given to you by the formula h of b minus h of a over b minus a. You would be my a, you would be my b. So h of b would be the same as h of 5, which is 34.3. H of a would be the same as h of 1, which is 73.5. And that's going to be over 5 minus 1, so over 4. Now, I'm not going to waste time going to a calculator and trying to find out what that is. I'm just going to wave my hands and tell you right now it's negative 9.8, which just so happens to be, never mind, negative 9.8. Let's just leave it at that. Okay, so that is B part 1, part I. Use the average rate of change found in I to estimate the height of the object at time t equals 3. Well, what the average rate of change does is it says if we were to start somewhere, if we were to go somewhere, how much is this changing per interval? What this is saying is from beginning to end, or at least from 1 to 5, this goes down by 9.8 feet, or what is it, meters? 9.8 meters every second. Okay, so if we're saying, all right, well, let's estimate 3 at 1, at t equals 1, we get 73.5. So if for every second we go down 9.5 or 9.8 meters, let's subtract 9.8 and then 9.8 again. That gets us to 2 and then to 3. And by doing that, we get 53.9. So estimate the height. So 53.9 meters. I probably should have said up here that this is meters per second. Okay, so let's just add another box right there. Look at that. All right, compare the estimate found in 2 to the value given by the model h of 3. So what I need to do is let's go back to our calculator. Let's use the model that we had, the equation that we had, and compare h of 3 to 59.3. And all right, so like I said, once I get rid of the calculator, it goes away. So let's type out negative 4.9 x squared. What was it? Plus 19.6 x plus 58.8. Now, we are being asked to compare this guy where x is 3. So I can find out easily where x is 3 or t is 3 by going down the table and getting 73.5, right? Now, how come in the last one we got 73.5 and now for this guy, or for the other one, we had 53.9? Why is it so different? Well, the actual picture that we're dealing with here, and let me hit zoom fit so I can see the actual picture. And if you're wondering, like, where is zoom fit? Zoom 0. The actual picture is this. Now, let me actually go to the window. I don't need negatives because this is a real life problem. So let me get rid of the negatives. Okay, let me get rid of all the negatives. That's the picture that we have. So we shoot off this object. It goes up in the air and then drops down. Okay, it goes up in the air and drops down. That's the actual object that we get. When we did the average rate of change, we just went from here and said, let's go down and let's go down, and here we are. Okay, but what's actually happening is we have something that's parabolic. It's an upside down parabola. So if I were just staring at the numbers when I found the average rate of change, the average rate of change doesn't realize that I'm actually going up and down. It just thinks I'm going down. Okay, so that's why there's a difference between the two. Now, just knowing the problem that I have ahead of time, what I'm also dealing with is if I hit second calculate, or if I hit table, second table, we start out at 58.8, and exactly at 6 seconds, we hit 0. What does that mean? That's the ground. At 6 seconds, we hit the ground. So I'm just going to use this to help me find part C when I get to part C, but we're going to answer both of those parts by just looking at the picture that I have here. So let's go back and do that. All right, so what I did using the graphing calculator is I found out that the actual picture looks like this. Okay, by finding the average rate of change, it only assumes that that's what we're dealing with. So the way that we're going to describe this is h of 3 is actually equal to 73.5. Okay, so, but the estimate we found was, what was it, 53.9? The difference is because the model is quadratic and since I'm running out of room, I'm going to say average rate of change doesn't factor that. It doesn't realize that. It just thinks it's a negative slope because you're just using 2 points. All right, so that's the difference between the two. There you have it. Now, what we saw in the picture is going to help us explain part C, which is how the range values of the function should be limited by the context of the problem. Now, the range values, and actually I was thinking it was domain values, but this is the range values. The range is going to be, and actually, you know what? I do need to go back to my calculator and find out what the maximum is. I think it actually might be that, but I might have to just go back there and find out what the maximum is. So I regret everything. Let's go back and do that. All right, I'm going to spare you and not make you watch me type in these values again. If I have to find the maximum, let me go back to window. Let's make this, I believe it was 0. All right, let me spare you and not make you watch me type this out again. Also, I had to fix my window to what I think should be fine. So when I hit graph, yeah, that works out okay. Now, once the range values. Okay, so the range values are going to be from 0 all the way up here. So let's hit second calc to find out what my maximum is. So 4 is my maximum. Go to the left, hit enter. For right bound, we're going to go to the right, hit enter again. And the maximum is 1.99999999999. So probably 2. So now that we know that the maximum is 78.4, which happened at 2, we can go back and say that the range is from 0 to 78.4. So let's do that. Ugh, back and forth. It's like me having a conversation with my father who has different political opinions as me. I'm just joking. He doesn't talk to me. That's the maximum, as we found. So the range is, we'll say you're allowed to include 0, and we were allowed to include 78.4 because that represents the height of the object in the sky. The height of the object. So you can't have negatives. And you can't have anything greater than 78.4. Or anything larger than 78.4. All right, so that's why. Because you have an object, you're shooting into space, you can't go greater than the thing that you get. You can't go to infinity. You can't go to the negatives because that would be underground, which is just silly. So that's problem 2. After this, we get 2 more, and no calculators allowed. Baby, hope this helps. Problem number 03 in the free response questions. Problem 3 is always going to be sinusoidal, and pretty much every single practice test I've seen has a picture that looks just like this. So whether you're going to be given a problem about a Ferris wheel or a grandfather clock or a pendulum or something swinging back and forth or bouncing up and down, you're probably going to see a problem that is sinusoidal. So let's talk about these two wonderful people, Dr. Chuckles McLaughlin and Congresswoman Penny Prankster. I think I voted for her. I don't know, she's not doing her job. They're enjoying a ride on a Ferris wheel with a radius of 30 feet. The bottom gondola, which these are called gondolas, the bottom gondola is positioned 3 feet above the ground and rotates clockwise once every 45 seconds. All right, so let's pause right there. You got yourself a circle. You got yourself a radius of 30. You got yourself the fact that this is 3 feet off the ground, which means if I were to label these, which I'm going to do in a moment, you know that you're going to be 3, and you're going to be 30 more than that, and you're going to be 30 more than that. Okay, so that's the information that I have so far when it comes to height. Okay, what else do I know? Well, it rotates clockwise every 45 seconds. So these guys are going to be, perfect line, Mr. Parrish. These lines are going to be 45 seconds apart, or these dots, A and E, are going to be 45 seconds apart. So this is going to go around 45 seconds later. So that's our period right there. So let's erase that ugly looking picture, and let's erase that because I'm not happy with it, and we'll probably draw something similar again. The Ferris wheel starts its rotation cycle when Chuckles and Penny board the indicated gondola. So right there. It also said it went clockwise, which tells us if something is going to start there and go clockwise, start at the middle and go clockwise up and to the right. It's going to be a sign, but we're not there yet. And by it's going to be a sign, it's going to be a sign and not it's going to be a sign. Okay. I saw one of those and it opened up my eyes. It's a base. The height of the Ferris wheel, h, is modeled by the sinusoidal equation h of t after t minutes. Great. The graph of h and its dashed midline for 2 full cycles are shown. 5 points A, B, C, and E are labeled on the graph. No scale is indicated. No axes are presented. Determine the possible coordinates of the 5 points A, B, C, D, and E. All right, so issue number one. We start right here, but that's not one of our points. But am I going to let that stop me? No, sir. No, ma'am. So I'm just going to say that if this is the beginning of our ride, we have time 0 at the height of 33. Now, if the period is 45, that means every time I hit a maximum back to midline, minimum, and back to the original is going to be 45 divided by 4. Okay, every middle, top to middle to bottom, every time I hit one of these 4 things is going to happen at 45 over 4 seconds later, and 45 over 4 is 11.25. So why does that matter to me? Well, that means the time for A is going to be 11.25. The time for B is going to be 11.25 more than that, so 22.5. The time for C is going to be 33.75. The time for D is going to be 45, which makes sense. And the time for E is going to be 11 more than that, which is going to be 46.25. Okay. Now the heights for these guys are obvious. 63, back down to 33, back down to 3, back up to 33, and back up to 63. So there's technically, since it doesn't tell me how many cycles are done in a cycle or whatever in a ride, I have an infinite amount of answers. But the obvious ones for me are the ones that start out at A, so 11.25, 63, B, which is 22.5, 33, C, which is 33.75, regular 3, D, which is 45 seconds, 33 at height, and E, which is 50. Oh, close one. That was a close one. 56.2563. All right. So, like I said, in pretty much every single practice test that I have taken that has free response questions, problem 3 is very, 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 very similar. And we answered these. Whether that gives you some kind of different sinusoidal thing, whatever, that's what we came up with. Now, part B is giving us all the same exact information, but asking us to write out the formula. Now, let's take a look at the information that we have. Whenever you are given a circular thing and you're given a radius, that is your amplitude. Your amplitude is always going to be the radius. So the radius is 30 because it goes 30 up that way, 30 down that way. Okay. Which, by the way, since this happens 3 feet off the ground, 33 is going to be my midline. So let's write that down here conveniently several spaces away. Okay. Now, we said that the period is 45. If this is a sine function, I need to find B, which is the frequency. The frequency for a sine or cosine function is 2 pi over the period that you came up with, which is 45, which I can't simplify that, so we'll leave that as 2 pi over 45. Don't know why I rewrote it, but I did. Now, since we started this at sine, since this starts here, right, and goes up and then down and then up and down. Remember, it starts here and then goes up and then down and then up and then down. We start where sine is supposed to start, just shifted up 33. Okay, just shifted up 33. So what is my vertical or horizontal shift? Well, I don't have one. There is no horizontal shift. Now, putting this in order, right, gives me my A, B, C, and D. So my amplitude is going to be 30, which means A is 30. B is my frequency, which is 2 pi over 45, me writing it out the third time. I don't have a horizontal shift, so C is nothing. And my midline is 33, so D equals 33, thus completing part B of our sinusoidal example. Now, this guy is typical of what you can expect to see for these types of problems. If you remember, the picture that we were given had A up here. Let's go back. Let me double check. Yep. Had A up here and then repeating at E. So you had A, you had B, you had C, you had D, and you had E. Drawn perfectly. It's telling me that the T coordinate for B is T sub 1. So this is T sub 1 something, who cares? We actually know what it is, but it's T sub 1. It's telling me that C's X value is T sub 2 something. Okay. Which of the following is true about H? H is positive and increasing. So H stands for height. So first things first, the height of the Ferris wheel is always going to be positive. So you guys are impossible because this says the height's negative. Buddy, you'd be underground and that's a Ferris wheel I don't want to be on. Now, from B to C, H is positive and increasing, or H is positive and decreasing? In this case, I know it's tempting. But you might be thinking, yes, the T value is moving to the right. That's not what I want. The T value might be increasing, but the height, my dear friends, is decreasing, giving us the answer B. Okay. Now, what 2 is asking is describe how the rate of change H is changing on the interval. Whenever you see the rate of change changing, that's concavity talk. Now, this is the same thing. This is the left side of concave up. The left side of concave up is decreasing at an increasing rate. So the rate of change is decreasing at an increasing rate. And that's how they want you to answer that one. All right, so that's the sinusoidal function. Expect something like that on pretty much all the pre-calculus AP exams that I've looked at. There's a bunch of them, and they're very similar for problem 3. So does that mean it's definitely going to look like that on the test? I don't know, but it's worth a shot. So this is what it's going to look like maybe. Hope this helps. Okay, so if you're looking at problem 4 and you're like, the heck is this? This is problem 4. On the actual AP Precalculus exam, free response question 4 is going to give you like these list of like directions that you need to follow. Otherwise, you're not going to get full credit. Like it'll tell you about like domains and stuff like that. Radians, you already know that. But, you know, the main thing here is if you can simplify something that's simplifiable, do it. Like, for example, if you're looking at like log base 2 of 8, you know you can write this as log base 2 of 2 to the third, which simplifies out to 3 and stuff like that. Okay, so if you can simplify them to whatever you can simplify them to, and you'll be good to go. Okay. Same thing here. If you can combine like terms and make that 5x, if you can combine like terms and make that 5 to the 5th, x to the 3rd, ln of 15 because you multiply the insides, do that. Okay. And so we will have a problem today that it will be a kind of a gross answer that we won't simplify. But again, if it's not a gross answer, try to simplify it because they're going to make you. So here we go. Part 4, question 4, part A gives us f of x and h of x, and they're both gross looking. Actually, f of x is the only one that's gross looking. The function f and h are given by f of x equals tan arc cos, which, by the way, I hate that. I'm going to rewrite it. Inverse cosine, 10 inverse cosine of x. Okay? Sorry, AP. I don't follow your rules. And then there's h of x, a bunch of logs. Solve f of x equals 5 pi for values of x in the domain of f. All right. Okay. So f of x in this case is 5 pi. All right. That's going to equal 10 cos inverse of x. Okay. This is problem numero I. All right. If I want to solve for x, I have to get rid of the inverse cosine, but first I need to divide both sides by 10. 5 pi over 10 is pi over 2, and pi over 2 equals inverse cosine of x. Whoa, 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 buddy, you might be thinking. The heck is all that space for? Well, in order to get rid of inverse cos, I can use regular cos. If the opposite works, then why not? Okay, cos of pi over 2 is what x value is going to happen when I do cosine of pi over 2? Well, 0, of course. So 0 is going to equal x, or x is going to equal 0, which happens to be in my domain. And so I'm in great shape. Problem I solved. Problem double I, which is what I'm called when I'm not wearing my glasses, says h of x equals 3. So 3 double I, 3 equals log, ignore that, log, and you know what? I'm not going to do it. 4 minus x minus log of 1. Fun fact, log of 1 is nothing. Get rid of it. So I have 3 equals log base 10 of 4 minus x. I have to unlock the x. How? Well, you take the base 10 of both sides. And what that does is these guys cross out. You have 10 to the third, which is 1,000, equals 4 minus x. Subtract 4, and let me write it over here. Negative x equals 996, and if negative x equals positive 996, then positive x equals negative 996. 6. That's an extra 9 that's not necessary. Oh boy, I wish they would put that in my paycheck. I'm on fire today. Okay? Part A, uno, dos unos. Nope. Hee. All right. Ugh. Rewrite p of x as a single logarithm base 2 without negative exponents in any part of the expression. All right, well, kind of what you saw in the little directions here, all the logs have the same exact base. Okay, if you add logs of the same base, you multiply the insides. That should be a B to make things easier. Otherwise, it would be a waste. What color am I using? Red. B is going to be log base B of AB. I have 6 of those. And if you subtract logs of the same base, you divide the insides. So it's going to look like this. And if you have a number floating around in front of a log, you can take that number and move it up here and make it an exponent like so. Yeah. So the first thing that I'm going to do is I'm not going to do anything yet, but move that 11 up there. So log base 4 of 2x minus 1 minus log base 4 of 3 plus x to the 11th power plus log base 4 of x to the 7th. These two we're subtracting. So let's do log base 4 of u, 2x minus 1, over u, 3 plus x in parentheses to the 11th. And we're still adding log base 4. Now, when you add two things, you multiply the insides, which is going to put x to the 7th up here in the numerator. So my final answer is going to be log base 4 of x to the 7th, parentheses 2x minus 1, close parentheses, over 3 plus x to the 11th. And I'm not going to simplify that because no one's going to want to simplify that. But that is a single logarithm. Now, what double I is asking for us to do is simplify this guy right here. Whenever you're being asked to simplify, if you see a cosecant, write it like the way it's supposed to be written, 1 over sine x. If you see a squared of a trig thing, try to find its Pythagorean identity. 1 minus cos squared x is the same as sine squared x. So why don't I put that over 1 for funsies? Oh, wait a minute. 2 sine x is on the top and 1 on the bottom? Well, let's cross u out. These 1s are useless, and I'm left with just sine x. So that's how I do that one. Sine x infection. I am on fire today. Ooh, part C, and the last thing. 3 times 4 to the x in parentheses squared over 2 to the x in parentheses times 2 to the 2x in parentheses. Find x such that r of x is 6. So r of x is 6 is going to equal 3 times. And you know what? I see these bases of 2's. Let's make 4 a base of 2. So that's going to be 2 squared to the x, which is 2 to the 2x, to the 2nd power over 2 to the x, 2 to the 2x. 3 is not going to combine with any of these. 3 is 3. Okay, so 6 is going to equal 3. When I have a parentheses with a power in it taken to another power, we multiply the exponents. So you become 2 to the 4x, 2 to the 4x. When I'm multiplying terms of the same base, I add the exponents. So 1x plus 2x's is 3x's. Ooh, I have 2 to the 4x over 2 to the 3x. When you have terms of the same base and you're dividing the one from the other, you subtract exponents. So 3 has not been bothered with yet. And 4x's minus 3x's is just going to be 2 to the x. Now what I can do is divide both sides by 3. The left side becomes 2, and 2 equals 2 to the x. If only I knew what the exponent was for 2. I do know it's 1. So if you have terms of the same base being equal to each other, set its exponents equal to each other, and 1 will equal x, or x will equal 1 because that's proper. That, ladies and gentlemen, concludes the ultimate GOAT test, ultimate AP Precalculus GOAT Volume 2. It's a lot, but I believe in each and every one of you to do it. So thanks for watching. Hope all of this helps. I love you, and hope this helps. I know I said it twice, but I have to end the video by saying hope this helps. So I hope this helps. Hey, hey, hey.